students, this is Mr. Ivan. Okay, so after looking through the paper 1 yesterday, these are my personal top 10 topics that I picked for paper 2 that you have to know, you must know, okay, before you go to exam tomorrow. Okay, there are of course there are some other topics that I left out, which are minor, but I think you still have to know it, which includes making a subject, okay, your normal algebra stuffs that you have to know. All right, now this paper is available for download below in the link. You can download it as PDF, try it yourself, and then check the answers, okay, or you can go through this video. I'm not going to tell you the answers for all the questions. I'm going to maybe give you some hints over here, and then maybe you should try it tonight, okay, before you go for exam tomorrow. Okay, the first topic that I feel will come out is standard form. Standard form has been pretty easy over the years. This is a number one is a pretty standard question about converting from nano to mega. Okay, you should try it and see whether you can answer. And the answer is incorrect. The answer should be 9.52 times 10 to the power of negative 18. Okay, so if you are unsure, okay, this is an easy question, I'll just do a quick one. So 0.00952 in nano means times 10 to the power of negative 9, and this is given already. So let's change it to standard form first. It's 9.52, okay, times 10 to the power of negative 1, 2, 3, negative 3, then times 10 to the power of negative 9, which means this guy is equals to 9.52 times 10 to the power of negative 12. Alright, now they want it in terms of omega, means you have to make 9.52 times 10 to the power of 6. So what do you need to multiply times 10 to the power of what that will make you equals to 10 to the power of negative 12? So it is 10 to the power of negative 18. So this is equals to 9.52 times 10 to the power of negative 18 mega seconds. Okay, yep, so this is an easy one. Alright, now the next thing is I realized that measuration is not tested at all in paper 1, so I have a feeling that measuration might be incorporated with either standard form, or it can be incorporated with Trigo in your 3-dimensional problems, or it can even come out in real world applications question. Okay, so make sure you know all your measuration formulas. Okay, this one I leave it to you to try and solve it yourself. The next topic, definitely it will come out with graphs. Most of us will hope that it is a traditional kind of graph question where they ask you to plot and draw and then find tangent, and then by including a suitable straight line. Okay, now if you go and refer to the 2018 real world application question, it involves asking you, so the question can ask you to, that the question may ask you to form the equation, okay, yeah, and then draw the graph to get the solution. Okay, so if you do not know what I'm talking about, refer to 2018 last question, okay, about forming the equation and then using the graph to get the answer. Okay, if not, most of the time they will ask you to draw a tangent at the point. Now there are two things I want you to take note. Number 2, which is, but now I tell you, in this case, the part 1 is quite standard, which they ask you to draw to find the gradient of the tangent at x equals to 0.5. Now, if I tell you that the gradient is negative 1, where is the point? That is the hard one. So first you must know that if the gradient is equals to negative 1, it means that the rise over run is 1. Okay, just that it's in a negative direction. So where rise over run is 1, so if I take 2 here, okay, and then 2 here, so in this case, this rise over run would be 1. So then use your ruler and look for the point whereby it is equals to 1, and you realize that it is exactly at here. Okay, so yeah, at here. Okay, so this is the trick to the question. Make sure your gradient is equals to 1 first, and then because it's negative, 1 means it's in the negative direction, and then move your ruler to a parallel point whereby it will hit a x coordinate. Okay, so this is how you find for part 2. For part 3 and part 4, including by adding a suitable straight line question, you should have to know you have to make left hand side the graph. Okay, these kind of questions you have to know. All right. Then for question 3, solving quadratic equation using algebraic fraction. Over here I give you 2 examples. One which involves circles, it involves radius. Okay, so for A part 1 is pretty easy. A part 2 is the hard one, where they ask you to find this guy. Alright, so you have to know that OX, the clue is OX is equals to OR minus RX. And what is OR? OR is the same as OA, which is the radius of the big semicircle. So what is the radius of the big semicircle? It is 2 times of 13 minus 6r. Okay, because this is 13 minus 6r over here. Alright, minus rx is 3r plus 1. Make sure you bracket it up. Then in order to form this one, I'll use a Pythagoras theorem to form and find the shaded answer. Alright, next is a very standard quadratic equation question with algebra. Okay, so the trick to doing this is always take the slower time minus the faster time, okay, equals to the difference. Alright, so before you get this, you should get 21 over x minus 21 over x minus 3. Okay, because if your speed is x minus 3, you're faster, equals to the difference. The difference is how much? 20 minutes, so it's 20 over 60. Okay, this is the equation you should be looking at. Alright, the next topic that I feel will come out is interior and exterior angle of in a polygon. Okay, so if you still do not know or still do not want to go and remember that the sum of interior angle formula, okay, then this is the best time to do it. It is m minus 2 times 180 degrees. Okay, and then the sum of exterior is always equals to sum of exterior is always equals to 360 degree. Okay, you also have to know a hexagon is how many sides, a decagon is how many sides. Alright, these 2 questions pretty standard. You have to know how to solve these 2 questions by now. Okay, number 5, it might come out as a separate question, it might come out as a real world application question. Okay, so there are 2 concepts that students always do mess it up. The first one is income tax payable. Okay, so maybe let's guide through you a little bit. Before let's doing this question, let's say my income, okay, and my income, okay, is equals to, let's say, 120,000. Okay, and then I have reliefs of maybe 50,500. Okay, so what is the income tax I pay? First part, always look for chargeable income. Chargeable income means your total income minus away 50,500. Okay, if you do not know what is income and relief, go to my Sec 1 playlist and look for this income tax video. Okay, and this would give you equals to 70,000. Okay, 70,000. No, 69,500. Okay, so this income tax payable is always based on my chargeable income. Now, first thing is, if this table confuses you, the first thing you should do is go and cross out these, go and cross out these numbers, the second numbers, okay? Go and cross out. All right. Now, why you go and cross out? Because these are the numbers that usually I find it confuses the student. Okay. So my chargeable income is 69,500. So where should I be looking at? I should be looking at here. Okay. So for the first 40,000, how much income tax do I need to pay? I need to pay $550. Okay. The next 40,000, it means that if I earn 69,500, first I must take away the 40,000, because for this 40,000 for sure I need to pay $550 already. Okay, so which means there is a 29,500 extra. Okay, so my total tax payable is equals to my first 40,000 I need to pay 550 plus how many percent for the next is 7%. 7 over 100 times 29,500. Yeah, and this is how I find my income tax that I need to pay. Okay, so in this question I gave you is if I tell you that the income tax I need to pay is 2,545, what is my chargeable income? Okay, so you have to work backwards to go and find the answer. All right. Okay, so like I said, this may come out in a real world application kind of question. Okay, the other one would also definitely be hire purchase, where you are paying things by installment. If you again still do not understand the concept of hire purchase, please go to my Sec 1 playlist to look for the video. Okay, next one, properties of circle, pretty standard that it will come out because it's not tested in paper 1. Paper 1 probably there is a little bit of properties of circle where it asks you to prove the congruent triangle. So but I'm also guessing that, you know, in properties of circle it might be linked together with radian measure. Okay, radian measure. Now for properties of circle, the first two things you should always look at is angle in the same segment. Okay, where this angle and this angle are equal, or angle at center, okay, is 2 times angle at circumference. All right, so try to look for these two things. All right, yeah, okay, but in this case this is not the most important. The most important in this one is the radius of any circle, okay, will form a isosceles triangle. That's probably what they want to test you on. Okay, and since it's incorporated with radian measure, remember how to find. Okay, you need to know how to find this part, okay, which is called a segment. There's a short way to find, it's called half r square theta minus, okay, sine theta. Now however, because this is in degree form, this is only for radian mode. Okay, now because this is in degree form and the formula for sector and arc length is not given in the degree form, but you have to know that area of sector in the degree form is theta over 360 times pi r square. Okay, and let's say if you need arc length, okay, is equals to theta over 360 times 2 pi r. Okay, whereas if you need to find the area of this triangle OAB, it is still, area of triangle is still half AB sine C. Okay, so try this out. Next one, standard property of circle question. Okay, try it. Okay, or get more practice from the tangent series. Okay, next, Pythagoras theorem and application of Trigo. Now there is a, if you look at, I think it's question 19, bearings have already been tested in paper 1, where they ask you to find the bearing of Singapore from Delhi and Tokyo. Okay, so they may not come out a bearing kind of question to test you on your application of Trigo. So what I reckon is it might be a 3-dimensional diagram, which is this, incorporated with measuration. Okay, it might also come out as a real world application question, asking you to find angle of elevation, angle of depression. Okay, so always remember, number 1, if it's right angle triangle, all right, then use Stochastic. Okay, use your normal Trigo. If not right angle, then use your sine rule and cosine rule. Okay, volume of this tetrahedron is a triangular in shape. Anything that is triangular in shape always have the fraction 1/3, okay, times base area, okay, times height. Yep, okay, try this as well. Very high chance something like this will come out where you know, sine rule, cosine rule is incorporated in angle of elevation in a 3D diagram. Alright, so I have two questions that is here for you to try. Alright, the next thing that will surely come out in the paper 2 is radian measure, which many students struggle because of the tediousness of this, but nothing you know hard. It is just tedious. Make sure you're accurate. Make sure if it is supposed to be in terms of pi, it is in terms of pi. If it's not supposed to be in terms of pi, make sure you use the raw value in the next part of your calculation, okay? And this you must try, okay? You must try. Now the most important two things of radian measure is the radius and the theta, okay? If you have no radius and no theta, means first you must find the radius first, okay? So if this is a center, here to here is called the radius. Yes, okay? Now what is here to here? Okay, because the whole part is, in this case it's pretty simple because the radius has already been given. This is the diameter, so which means that the radius is equals to, yeah, 30. Okay, so this is equals to 30. Yes, okay, and then you have to find, and then this is 55 divided by 2. Find out what is this, or let's not use this, find out what is x using Pythagoras theorem. Okay, and then you can find out the depth of the water in the pipe. Okay, so sometimes when you do not have the r, try to use this way to form a right angle triangle to find your radius. Alright, and number 9, vectors, proving of collinear and fraction, definitely will come out one question. Okay, you should have done enough practice about vectors at this point of time. Okay, answer is given here. Alright, next and the last part is measuration. Measuration, it might come out as a separate question on its own, but I think high chance it will come out as a real world application where because measuration we can always tie in with rate, we can always tie in with volume, we can tie in with area, we can tie in with money, we can tie in with amount of petrol, etc. and etc. Okay, so make sure you understand clearly what does the question wants. Okay, whether do they want area, whether do they want volume, okay, and then apply accordingly. And remember, the important part about measuration is when an object is recast. What do I mean by recast? So for example, let's say I have this, okay, a cone, I recast it to a sphere. Alright, the volume is the same, remains unchanged, unchanged. Okay, so when you melt the cone to become a sphere, okay, the volume remains, okay, unchanged. So that is the important thing about volume that you have to know. Alright, and the next part, okay, which is also super important, is and I find that many students do not understand this concept, is this is a radian measure into a measuration kind of question. So this is like a sector. This in AOB is a major sector. Now a sector can be converted into a cone. Okay, so you must be very clear that the radius of the sector has now become what of the cone? Now become the slant height of the cone. Okay, that is super important. Now to find anything with regards to the cone, you will need the radius of the cone. So how do you find the radius of the cone? You probably, because you can find the area of the sector, and that will become equals to the area of the cone. Area of the cone is pi RL, yeah, and this is equals to the area of the sector. Alright, and this is how we find the R of the cone. try it out. And this is a very interesting question. And of course, again, like I say, measuration has not been tested, and I highly likely think that it will come out as one of the few questions in your paper 2. Okay, so all in all, these are the top 10 topics that I feel you have to know. Again, if you really cannot solve any of the question and you feel that you need help, DM me. I will try to send you the video solutions, okay, because I also have lessons in the evening. Alright, good luck and don't be careless.